Hello world, welcome to TOC. My name is Abhishek Rajan. Today in this lecture we are going to see how to reverse an array using recursion in Java. So this is an array. It contains altogether 6 elements. So size of this array is 6, and the indices are ranging from 0 to 5, and we have to reverse this array. So as you can see, the elements of this array are 10, 20, 30, 40, 50, and 60. So when we reverse this array, this has to become 60, 50, 40, 30, 20, 10. This should be the result. Sorry, my pen is behaving weirdly. So when we take a look at this array, so how this has to be reversed. So in that case, the value at index 0 should be exchanged by value at index 5. The value at index 1 should be exchanged by value at index 50, index 4. The value at index 2 should be exchanged by value at index 3. So eventually, as we are writing a function, so array should be passed in there, and some start index and some end index should be there. This n s stands for its start index and e should be for end index. So as you can see, for every next recursion, the value of I is, let's say this is the start, or let's say this is the start, and let's say this is the end. Okay, so as you can see, the initially the recursion is going to happen on 0, 5, and next time the recursion is going to happen on 1, 4, and then after that the recursion is going to happen on 2, 3. So this is the start index and this is the end index. So as you can see, this is the function. Let's say this is the function in which we are passing the argument array, start index, and in end index. So every recursive call should be passed by incremented value of start and decremented value of end, right? Because in the next iteration, start from 0 is going to become 1 and end from 5 is going to become 4. And again in the next iteration, the start from 1 is going to become 2 and the end from 4 is going to become 3. So this is how the behavior of the start and end pointers are going to happen. This is why I have provided here the incremented value of start and decremented value of end. So this was the case with the array having even number of elements. So let's take another example in which we have an array having odd number of elements. So in the odd number of elements, there is a little bit of change which we can counter. So let's say the value at index 1 and the index 0 is going to be exchanged by value at index 4. Value at index 1 is going to be exchanged by the value of index 3, and value of index 2 is going to be exchanged by itself, or we can also put a condition where it is not going to be touched, right? So in this case, so actually this is the 5 elements. There are 5 elements in this array and the values are ranging from 0 to 4. So this is why there is a single element at which the swap is not going to be the swap itself is not going to make any effect, so this can be ignored. So let's say this is the start, let's say this is the start and this is the end, or let me be more precise, let's say this is the start and this is the end. So when start is smaller than end, this should happen. Here also start is smaller than end, and when start is not smaller than end, then this recursion should be stopped. So this will not happen, right? The swap at 2 is not going to happen when we are stopping here. So what I'm talking about the base condition here, base case, the case at which recursion should be stopped. So in this case, I should write if start is if start is greater than end or equal to end, greater equal end, then it should be stopped. So how can we stop it? Using the return statement, right? Using return statement, we can stop it. Now, what about the swap? How, when, where can we do this swapping? So this is the base case, and this is the swapping logic, and this is the recursive call. So this is the base case, this is the base case, and this is the swapping. Here we have to write the swapping logic, and here is the recursive call. So now let's talk about the swapping logic. Let's say we have been given two elements, array of 0, array is an element of array at 0th index, and element of array at 5th index. So this we have to swap, right? So what we can do, a at 0th index, I am assigning the value at 5th index, and at 5th index, I am assigning the value at 0 index. So what is going to happen? The value at 5, that means A is going to attain 60 value, and again, if I am doing A5 is going to be updated by A0. So this value at 0 is 60 now. So 50 is going to be updated by the fifth element is going to update it by 60 itself. So 0th index and 5th index both are going to have 60 only, right? So in this case, what should we do? Before updating the value at 0th index, the value at 0th index should be updated in a temp variable. Okay, this value is going to update it in a temp variable, and finally, and then I'm going to update, we should update the value at 0th index by a value at 5th index, and value at 5th index should be updated by temp. This is what we have to do in the swapping. So let's see how we can write the code for this. So I have so this is a small program in which I'm going to demonstrate you uh, the writing of the recursive code. So I have the array here, and here I am going to print the elements of array. So here I am going to call a recursive call. I'm going to call a function reverse, and here I am passing array. And as I said, here we need to pass two variables. The start and the end, right? So the start is 0 and the end is array dot length -1. Why I am doing this? Because can you see how many elements it has? It has 6 elements. It has six elements, but the last index should be 6 minus 1, that is 5. Because it has got 6 elements, the indices are ranging from 0, 1, 2, 3, 4 to 5. So 6 is not going to be there. Only till 5th the elements are present. So now this is fine. That's why I have written length -1. So now I'm going to call this private static void reverse int array int start int end. Fine. Now as I said, we need to call the recursive function with every time with incremented value of start index and decremented value of end index. So let's do a reverse call of reverse function array start plus 1 end -1. So this has been done. And now when we have to stop the recursion, that is the base case, this is the recursive call, and when we have to stop the recursion, that is the base case we need to write. When we have to stop the recursion, if start is going to become greater or equal to end, this should be stopped. And now this swapping logic, here this swap logic. What swap logic we have to do? So you can see here we need to take a temp variable and then assignments, right? We need to take a temp variable, temp equals, I need to assign that start index value, and then again at start index I need to update the end index value, and at the end index need to update temp. So this is what we had to do. Now let's run this code and see how it happens. So it has been reversed 50, 40, 30, 20, and 10. So let me change the size of array by adding one more element. Now previously it was for odd number of elements. Now it is for even number of elements. So let me see how it happens. So this is fine. So this is going to reverse the even number of elements as well. So let us do one modification in the code. Now let us do one more modification in the code. As let me take a screenshot and let me paste it here. Or else let me explain this in this way. So as you can see, we have a function call. We have array, or let me take a small. This is array, this is start, and this is end, right? And we have the base case, that is if start is greater equal end. Sorry, start is greater equal end. We should return, right? And here we have written the swap logic. And here the recursive call again by incrementing one value in start and decrementing one value from end, right? So the swap logic, every time the function is going to be executed, it checks the base case, it checks the base case, and it does the swapping and do the recursive call. The swap logic can be written here as well. So once after the returning, so in this case what will happen, so a stack is going to be filled with the function call. So in this case, when the function call is going to be written before the swap logic, so first the recursive call is going to happen one after the other. First the recursive call, the function is going to be called, so once it will return, so after returning from here, the swap logic is beneath this, and this code is going to be executed. So if we write the swap logic right before the recursive call, it is not going to make any difference. So what I wanted to demonstrate, so let me run this. 60, 50, 40, 30, 20, 10, and let me take out one element so that we can check it for the odd number of elements. So this is fine. I think this code and this fundamental is clear to all of you. So please like my video, please subscribe my channel, and please click on the bell icon. Thank you for watching. Thanks, gentlemen. Bye bye.